the 2002 National Electrical Code, equipment grounding conductors are not required for service under specific circumstances. The key condition is when there are no electrical connections between the service conductors and the building or structure itself. This is not explicitly stated as a broad exception, but rather inferred from the wording of Section 250.23 ATWA. Section 250.23 ATWA focuses on the grounding electrode conductor connection at a service. To understand this inference, we need to analyze the context and the overall intent of grounding requirements in the National Electrical Code. The primary purpose of equipment grounding conductors is to provide a low impedance path for fault current to return to the source. This low impedance path facilitates the operation of overcurrent protective devices such as circuit breakers and fuses, thereby clearing the fault quickly and minimizing the risk of electrical shock or fire. When there are electrical connections to a building or structure, the equipment grounding system bonds all non-current carrying metal parts together, creating an equipotential plane. This ensures that in the event of a fault, the voltage potential between different metal parts is minimized, reducing the likelihood of a shock hazard. However, when the service conductors are isolated and have no electrical connection to the building or structure, the risk of a fault causing a dangerous voltage potential is significantly reduced. Consider a scenario where a detached garage or shed is supplied by a service drop or underground lateral. If the only electrical connection to the structure is the service conductors themselves and there are no metallic pathways such as water pipes or gas lines bonding the structure to the main building, the need for a dedicated equipment grounding conductor becomes less critical. In this situation, the grounding electrode system at the detached structure provides a local ground reference, and the service conductors are effectively isolated from the building's grounding system. The inference that equipment grounding conductors are not required in this specific case stems from the understanding that the primary function of these conductors is to provide a low impedance fault current path within the building or structure. If there is no building or structure to connect to, the necessity of this dedicated fault current path is diminished. It's important to note that this exception should not be interpreted as a blanket waiver of all grounding requirement. Even in the absence of a dedicated equipment grounding conductor, the grounding electrode system at the service location is still essential for establishing a ground reference and mitigating the risk of ground faults. Furthermore, local amendments or interpretations of the National Electrical Code may impose additional requirements, so it's crucial to consult with the authority having jurisdiction to ensure compliance. The exception described above primarily applies to services where the conductors are physically isolated from the building or structure. This isolation prevents the transfer of fault currents from the service equipment to the building's metal components. Examples of situations where this exception might apply include services supplying power to equipment mounted on poles or pads away from the building, or services supplying temporary construction power. It is essential to distinguish this situation from cases where the service conductors enter a building and supply power to equipment inside. In those cases, equipment grounding conductors are always required to ensure the safety of occupants and the proper operation of overcurrent protective devices. The National Electrical Code provides detailed requirements for sizing and installing equipment grounding conductors. These requirements are outlined in Article 250, and they vary depending on the size of the service conductors and the type of grounding electrode system used. In general, the equipment grounding conductor must be sized large enough to safely carry the available fault current without overheating or causing excessive voltage drop. It is also important to ensure that the equipment grounding conductor is properly connected to all non-current carrying metal parts of the electrical equipment and the building's grounding electrode system. Failure to properly install and maintain equipment grounding conductors can create a significant safety hazard. Fault currents may find unintended paths to ground, resulting in electrical shock, fire, or damage to equipment. Therefore, it is essential to follow the requirements of the National Electrical Code and consult with a qualified electrician to ensure that the equipment grounding system is properly installed and maintained. Now, let's consider some specific examples to illustrate the application of this principle. Firstly, Imagine a situation where a utility company provides a service drop to a piece of equipment located outdoors, such as a pump or a generator, that is not physically attached to a building or structure. In this case, the service conductors are isolated from any building components, and the equipment itself is grounded through a separate grounding electrode system. Because there are no electrical connections to a building, the exception described in section 250.23 ATWO would likely apply, and an equipment grounding conductor would not be required between the service equipment and the grounding electrode. Secondly, consider a temporary construction site where power is supplied through a portable generator. The generator is typically grounded through its own grounding electrode system, and the temporary wiring is run to various pieces of equipment. If the temporary wiring is not connected to any permanent building structures, the exception may again apply, and equipment grounding conductors may not be required for the temporary service. However, it is crucial to verify this with the local authority having jurisdiction, as temporary wiring installations often have specific requirements. Thirdly, imagine a situation where a small shed is located some distance from the main house. This shed is supplied with power via an underground feeder, and the only electrical connection between the shed and the house is the feeder conductors themselves. If the shed has its own grounding electrode system, and there are no other metallic connections between the shed and the house, an equipment grounding conductor may not be required between the feeder panel in the shed and the grounding electrode. However, it is essential to ensure that the feeder conductors are properly sized and protected by overcurrent devices, and that the grounding electrode system in the shed is adequate for the intended load. It's important to reiterate that this interpretation of the National Electrical Code relies on the absence of any electrical connections between the service conductors and the building or structure. If there are any metallic pathways such as water pipes, gas lines, or structural steel connecting the service equipment to the building, equipment grounding conductors are absolutely required. Furthermore, the National Electrical Code contains specific requirements for grounding and bonding in agricultural buildings, healthcare facilities, and other specialized locations. These requirements may differ from the general rules outlined in Article 250, and they should be carefully reviewed and followed. In addition to the technical aspects of equipment grounding, it is also important to consider the legal and regulatory implications. Electrical installations are subject to inspection and approval by the authority having jurisdiction, and failure to comply with the National Electrical Code or local amendments can result in fines, penalties, or even the shutdown of the electrical system. Therefore, it is essential to work with a qualified electrician who is familiar with the local codes and regulations and can ensure that the electrical installation is safe and compliant. In summary, the exception to the equipment grounding conductor requirement for services described in section 250.23 ATWO applies only in very specific circumstances where the service conductors are completely isolated from the building or structure. This exception should not be interpreted as a general waiver of all grounding requirements, and it is essential to consult with a qualified electrician and the authority having jurisdiction to ensure compliance with the National Electrical Code and local regulations. Remember that electrical safety is paramount, and proper grounding is essential for protecting people and property from electrical hazards. Now let's discuss some additional considerations related to this exception. One important point to remember is that even if an equipment grounding conductor is not required, a grounding electrode system is still necessary at the service location. The grounding electrode system provides a reference point for the electrical system and helps to stabilize the voltage potential, minimizing the risk of ground faults. The National Electrical Code specifies the types of grounding electrodes that are permitted, as well as the methods for installing and connecting them. Common grounding electrodes include ground rods, ground plates, and metal water pipes. The size and type of grounding electrode required will depend on the size of the service and the local soil conditions. Another important consideration is the potential for induced voltages on the service conductors. Even if the service conductors are isolated from the building or structure, they may still be subject to induced voltages from nearby power lines or equipment. These induced voltages can create a shock hazard if they are not properly grounded. Therefore, It is essential to ensure that the service equipment is properly grounded to mitigate the risk of induced voltages. In addition to the technical requirements, it is also important to consider the practical aspects of equipment grounding. Equipment grounding conductors should be installed in a neat and workmanlike manner, and they should be protected from physical damage. All connections should be tight and secure, and they should be inspected regularly to ensure that they are in good condition. If any problems are found, they should be corrected immediately to maintain the integrity of the grounding system. It is also important to keep accurate records of the grounding system, including the location of grounding electrodes, the size and type of grounding conductors, and the results of any inspections or tests. These records can be helpful in troubleshooting problems and ensuring that the grounding system is properly maintained. Finally, it is important to remember that the National Electrical Code is a living document that is constantly being updated and revised. It is essential to stay informed about the latest changes to the code and to ensure that all electrical installations comply with the current requirements. The National Electrical Code is available for purchase from the National Fire Protection Association, and it can also be accessed online through various subscription services. In addition to the National Electrical Code, many states and local jurisdictions have their own electrical codes that may be more stringent than the national code. It is important to be familiar with the local codes and regulations in your area and to ensure that all electrical installations comply with these requirements. Working with a qualified electrician who is familiar with the local codes and regulations is essential for ensuring that the electrical installation is safe and compliant. In conclusion, the exception to the equipment grounding conductor requirement for services described in Section 250.23 at-O of the 2002 National Electrical Code applies only in very specific circumstances where the service conductors are completely isolated from the building or structure. This exception should not be interpreted as a general waiver of all grounding requirements, and it is essential to consult with a qualified electrician and the authority having jurisdiction to ensure compliance with the National Electrical Code and local regulations. Remember that electrical safety is paramount, and proper grounding is essential for protecting people and property from electrical hazards.